Hey there, welcome to a video discussing 2.3. This is called Applied Deductive Reasoning. And you can see right below in italics, it says, when in doubt, use your common sense. So here you're asked to crack a code. And it's kind of tricky, but when you see the numbers 3, 4, 2, so what you're trying to do is you're trying to find a 3-digit number. It took me actually a minute to figure out what these instructions want us to do. So don't worry if you're a little confused. What you're trying to do is you're trying to find a 3-digit number. And these are your clues. So 3, 4, 2 means that there's no 3, no 4, and no 2 in our 3-digit number. So 3, 4, 2 are not any of the digits. Likewise to 2, 7, 3. So remember we have 10 digits that we could use. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's no 2. There's no 3. There's no 4. And there's no 7. So those 4 digits are out. So then to say that here, 2 numbers are correct, only 1 is well placed. So like 1, 6, or 5 could exist. Oh, how did I forget to write the 6? Oh my goodness. That was silly of me. Probably thinking, hey, Mr. E, forgot to write the 6. Okay. And of course, there's no 7. So you could have a 1, 5, or 6. And but only 2 of those are correct, and only 1 was well placed. You have an 8, 5, or 3. But we know the 3 can't exist, right? So that means we definitely have an 8 and a 5. And here, 2 numbers are correct, but 1's wrong place. But if we know if we have 8 and a 5, then we're not going to have a 6 because only 2 numbers are correct. So 6 is out. So it means you definitely have to have a 1. So now our numbers can have evolved 1, 5, 8. And then they said here, only 1 is well placed. And here, everything's wrongly placed. So the 5 is in the last spot. So it means that the 5 is not in the right spot in that third clue there. So the 1's in the right spot. Meaning that then the 5 is going to have to be over here and leaving the 8 over there. Because again, everything's wrongly placed in that last clue. So 5 is definitely in the last spot, and 5 shows up in the last spot in the third clue, meaning the 1 has to be the correctly placed digit. And so there's your code. So this is using deductive reasoning, where you're using clues to draw conclusions. That's kind of the big picture here. So it's kind of just making you think a little more logically. That's what the whole point of this section is about. So, like for example, deductive reasoning. If A equals B, then B equals C, then A equals C. Yeah, that's kind of true, right? I mean, obviously, if if 4, if A happens to be 4, B is 4, and B equals C, C is 4, then all these numbers equal 4, right? Sometimes it doesn't work. Like if you were to say, like if the Warriors beat the Kings and the Kings beat the Lakers, then the Warriors beat the Lakers. Of course, that may not always be true. Maybe the Warriors bench all the players or they get hurt, and maybe Anthony Davis comes back for the Lakers, who's always injured, and they happen to beat and the Warriors on the back-to-back. I mean, sometimes this doesn't always work in real life, but yeah. But in this case, if if you're looking at just pure numbers. Yeah, if A equals B, B equals C, and A equals C, that's deductive reasoning. Inductive reasoning is more things that are implied. And kind of working backwards. So here, if the measurement angle is 90 degrees, that's a right angle. We know this. If that's 90 degrees. You can actually make it a right angle. Well, if angle A is less than 90 degrees, then angle A is not a right angle. So that would be implied that it's not a right angle. And you're kind of working backwards. Mary goes to the movies every Friday and Saturday night. Today's Friday. Then Mary goes to the movies. So what you're doing, when I say working backwards, let me rephrase that. Is that you're given a conclusion. So state the correct hypothesis. So that's why it's working backwards. Because here's your if, here's your then, and of course here you're told, so that's A and that's B. So you're told not B, then not A. Because remember, contrapositives are logically equivalent to original statements are true. And if that's your if she goes to the movies, then it's Saturday. So it's or Friday or Saturday. So it's Friday. So she goes to the movies. And that's was a biconditional because it's every Friday and Saturday. So have you guys tried this on your own? Well, let's just see here. Actually, let me do part A with you. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse's Rick's lab partner, then Rick will get an A in chemistry. So then you could say, if Rick takes chem, then he gets an A in chem. Yeah, because that's A leading to B, and that's B leading to C, therefore A leads to C. That's a lot of syllogism. That's what pronounced as syllogism, and that's what's being said up there. So you're doing something similar for parts B and C. So I'll have you guys try that. And then here, use both deductive reasoning to come up with a solid conclusion. What conclusion can you make about the product of an even integer and any other integer? Okay, so even integer, say 2, any other integer could be like 1, 2, 3, 4, and so on. So if you do 2 times 1, you get 2. If you do 2 times 2, you get 4. If you do 2 times 3, you get 6. If you do 2 times 4, you get 8. So it seems that it's always even. I guess if you use inductive reason, you could say, I'm trying to think here. If a number is even, its product or it is a product of at least one even number. I suppose that's how you could do it through an inductive reasoning, but the bottom line is this, is that we know that if you do 1 times 2 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. It's always even. And that's really more using deductive reasoning because we're doing a lot of different examples, and that's what we're noticing. So just use your common sense, really. Don't worry so much about the labeling of deductive or inductive. Let's look at this one more time. Decide whether inductive or deductive is used to reach a conclusion. Explain your reasoning. Each time Hope kicks a ball to the air, it returns to the ground. So the next time Hope kicks a ball up in the air, it will return to the ground. Yeah, that would be more inductive, I believe. Reptiles are cold-blooded, parrots are not cold-blooded. Sue's parrot is not a reptile. That would be deductive. Because what you're doing is you're saying, you know, A leads to B, and then, you know, well, parrots are not cold-blooded, so it's not a reptile. So it's kind of looking at, you know, two different statements. Where it rains in the morning after baseball games are canceled, baseball game this afternoon was not canceled, so did not rain this morning. That'd be deductive also. Every time Tom is eating strawberries, he has an allergic reaction to eat strawberries. He'll have, yeah, and I believe that's inductive. It's kind of weird, actually. You know, don't really worry about this so much. Yeah, don't worry about it. It's kind of weird. So I'm gonna just cross this off. Interestingly, you know, here you're looking at women's soccer player Hope Solo. At later time asked me about my kind of cool connection I have with women's soccer. Two of my former students are actually on the women's soccer team. More happy to kind of share more details about that at a later time. One was 2011 for my school, graduated 2016. Abby Dahlkemper and Tara Davidson. So if you guys happen to follow women's soccer, those are both my former students, and they've done obviously very well. So I kind of have a kind of a neat connection there. I'm a terrible soccer player. I don't really like watching soccer that much, except if it's on the big stage or if I have former students who are playing. Anyway, but Hope Solo, she was on the previous team. She didn't play with my former students. She's now not on the team anymore. Anyway, we'll end this video.